Okay, everyone, let's start. So, hello, everyone, and a very warm welcome to Tech Winter Break 24. I am Athar Vasate, serving as the technical lead of GDGC for this tenure. We are thrilled to have you join us for this exciting 2 day journey of hands on learning and innovation. For those who don't know us already, guys, please stop living under a rock. We are a university based community of developers where we turn caffeine and curiosity into cutting edge code. We are basically the Avengers of the student tech world, except our superpower is solving problems with latest tech and a lot less collateral damage, of course. Whether you are a newbie or still figuring out what Hello World is all about, or a coding prodigy who dreams in binary, GDGC is your squad. We are all about learning, building, and fixing stuff together. Think workshops, hackathons, and all those eureka moments that make tech so exciting. At GDGC, we don't just talk the talk, we build the builds. From helping local businesses go digital to crafting ideas that could reshape the future, we are here to turn potential into prototypes. And hey, who says you can't have fun while becoming a world class developer? I would like to take you through our schedule on the day one. We are going to have a hands on workshop where you would be learning to build a movie recommendation system using machine learning. And on the day two, you will be learning to build math equation solver app using Gemini and Flutter. Also, we have shared a document in the chat which has the prerequisites that you must do before starting to code. So kindly complete all the steps mentioned in the doc. Also, guys, since we have time constraints, we won't be able to address all of your doubts and errors, but we will open the chat section momentarily from time to time to take up your doubts. So please save your doubts and ask them in the chat section whenever you get the opportunity. So buckle up and get ready with your IEDs. I once again welcome you all to Tech Winter Break 2024. And as you embark on this journey, remember, may the bugs be with you. Now, I would like to invite the web team to take over from here.
Yeah, thanks Athar for a wonderful introduction. Hi everyone, I'm Shashwat and I'm the web lead for this tenure of GDG, and alongside me is Ishank, he's the web co-lead. Today we are really fortunate that the ML team is also collaborating with us. The ML lead is Arihant and the ML co-lead is Sahil Garje. As the saying goes that a leader is as good as his team, which holds true. We have a really talented pool of individuals in our team, and the web team members include Harshvardhan, Vaibhav and Arunava. For the ML team, we have Anant. So what are we building? Have you come across a scenario where you might have watched a movie and you might want to watch similar movies like that? Well, that is exactly the problem we are solving. So while solving the problem, what features you can learn? You can learn, next slide. So what are the features which we can learn? We can learn user machine learning integration, dynamic data fetching, user interaction, curated movie list, personalized recommendation, and enhanced user experience. We have also divided our presentation into three phases. The first phase includes the front end, the second phase will include the machine learning, and the third phase, the back end. So what tech stack are we using for the front end? We will be using React and Tailwind for styling. So what is React? React is basically a JavaScript library which helps us to build amazing web apps. What are the good features of React? I would say component reusability and virtual DOM for faster updates and a declarative programming model for predictive and easier to debug code. Why are we using Tailwind? Tailwind is a utility-first and highly customizable CSS framework that allows developers to rapidly build modern responsive designs directly into the HTML. So I guess we are done with the introduction, and I'll just once again move you to the prerequisites you require. Now you can just open your terminal and write git clone and copy the link which is shared in the chat. Git clone, I once again repeat, git clone, and just copy this link. And now you will have a folder downloaded in your VS Code. With the folder downloaded, just open the terminal and write npmi. I repeat, npmi, and you will be good to go as you have installed now all the dependencies. Now let's start coding. So what are we going to do here? We basically have some dummy data, and I'll be teaching you how you can display the data using a map function on the website. So as we can see here, we have app.jsx component, which is the main function, and here we render all our components. what I want you to do is open the component section and move to the movie list section component. Here you can see we have an array of objects, and in this array of objects we have many objects, and they have their properties like ID, name, and rating, and so on. So let's start the coding. This is a div, and this will act as a main container. I'll be adding some CSS for styling purposes. I'll be adding a padding of 6. So the padding basically ensures that there is enough space between the border and the content we are writing. I'll guess white color look good, so I'll be adding the white color, and the minimum height of this component should be equal to the height of the screen. Also, I'll be adding a margin top so that there is enough spacing between the top component and this component. Basically, now what I'm doing is I'm adding a heading, and our heading will be movie list. Let's say movie list. I'll be using an h-word tag for this as a heading, and I'll be adding some CSS once again. As it's the heading, the font should look big. That's why I'll be adding text as 3XL and the font as bold. Now, any heading looks good when it's in the center, so I'll be adding the text as center. So this will create a heading tag, and now I'll move on back to the app.js6 component, and I'll just import my movie component so that it gets shown on the screen. Now, as you can see here, now if I save it on my screen, now we will have a movie component. Now, coming back to the component again, I'll create another div. This div will contain all the card components of the movie. I've created a div, and I'll be using for styling, I'll be using a grid. So basically, a grid is used for styling purposes, and it ensures that the arrangement is in columns and rows. I'll just add the class name, and as I said that the styling will be grid, and for small, let's say that for responsiveness, I'll say that there is one column for a smaller screen, and for a medium screen there will be 3 components, there will be 3 columns, and for larger screens as a laptop there will be 4 columns. So, and I'll also add a gap so that the card components, they have enough spacing so that it looks good. So now I'll be teaching you how to use a map function. So basically, a map function works on an array and it returns a new array. It accepts a callback, and what it does is a callback is basically a function which is passed inside another function. So what the map function does, it uses that callback and applies it to every item of the array. So as you can see that the name of the array here is movie, and I'll just add a map function, movies.map. Now we'll be using an arrow function here, and I'll be passing a parameter here. This will represent the current element. It can be any name, you can name it XYZ, but I'll be naming here as movie. Now I'll be creating another div, and this div will contain all our card components. Yeah, so there is, as you can see that there is a ID for each and every JSON element. So what I'll do is I'll name it as key, and using the dot operator, I will say that it's ID. So as I told you that the movie component, the map component will iterate for each and every element of the array, and by using the dot operator, I'll access their ID. And I can also add a class name, and I can also add a class name here. So the class name, this positioning will be relative, so that every child element will be inside it would be absolute, and I will keep the borders as rounded, And to ensure that nothing goes out of the card component, I will say that the overflow should be hidden. Now I'll be adding the boundary of the card component. So I'll be creating another div. And again I'll keep the styling as relative. The background should be black. The text should be white.
Excuse me, Shashwat. I think your screen is frozen. You can start the sharing again if possible.
Yeah, wait.
Also, Shashwat, increase the font size of your VS Code terminal
Sure.
ID.
Yeah, is my screen visible again? Guys, is my screen visible?
Yeah.
Okay.
Yes.
So, is the zoom fine?
Can you do it slightly more?
Okay.
I feel your VS Code is still frozen.
Is it working fine now?
Try making it on full screen.
Yeah, it's full screen.
No, it's not visible. It's still stuck.
Wait, I'll share the entire screen again and let's see if the error goes. In any case, I'll explain the code. If the screen is not visible, it's not an issue. Yeah, is the VS Code visible again?
Yes, now it's visible. Yes,
And
now it's working. Yes,
it's working,
it's perfectly working. Yes.
Okay.
Don't
Yeah.
have it full screen. I feel it when making full screen, it's not working.
Is it fine now?
Yes, now it's working.
Yeah, I'm really sorry guys for this issue. Yeah, so I'll continue. So what I was saying is that now this div will contain the border of the card component. So again, I'll keep the styling as relative, and we can keep the border color as yellow. You can choose any color. I'm just like, I like yellow. That's why I'm making the color as yellow. So basically what we have to do is now that we have to also insert an image. So we'll be using an image tag for that. And in this source, what we have to do is that we have to put the path of the image. I've already defined the path in the objects file. So again, as you can see, that movie is the current object, and I'll be just using the image, and I'll be using the dot operator to display the image. Now I'll be using another div, and in this div, all the elements inside, all the content inside the card component will be shown, like the movie name and the movie rating. So again, just to ensure that there is enough space, I'll be keeping the padding as 4. You can choose any padding you like, guys, and you can, like, I would recommend you to try it as it really improves your CSS skills. Yeah, so what we have to do is now we have to tell the movie heading. So I'll be using an h2 tag for that. And what I'll do again is that I'll again use movie, which is the current element, as I've already told you here. And I'll be using the dot operator again, and it will display movie.name. Now I'll be using a paragraph element, and this will display what is the rating of the movie. Again, I repeat, if you have been following me, movie is the name of the current element, and I'll be using the dot operator, and then just I'll write rate. So this will tell what is the name of the movie and the rating of the movie. Now I'll be creating another div, and inside this div, you can see that there's another object here, and it contains an array. So these are the genres. So what we'll do is we'll again use the map function here, and so that each of the genres get displayed. So let's say I'll again do some CSS styling. I'll add some margin top, and for this time I'll be using flex as a styling. Flex aligns all the items inside it in a horizontal axis. And I'll again use the map function. So here we can see movies is the name of the array, dot genre to movie is the name of the current element, and genre is the property which we want to access. And genre, as I've already shown you, it's already an array. So I'll be using the map function here, and I just say genre, and I'll assign an index to the element, and this is again an arrow function. Yeah, command, and this is again an arrow function. So I'll be creating a span tag here for styling purposes, and for this span I'll be using a key. Key will act as an index, and I'll be using, and for styling purposes again I'll use the class name, and I'll add some padding and some text clear. As we are running short term time, I will be able to make it too beautiful, but I hope that you're getting a gist of what I'm trying to say. And here I'll just write genre, because genre is the current element which we are trying to display. Now what we have to do is, now all of this is done, we'll just add an add to cart button, which will basically add any, which will select any element and it will add to the cart. So I'll just create a button and just write add to cart. So this basically completes my code, and like there are some errors, but we can fix as well in short on time. I won't be able to debug it, and now Ishank will take over from here.
Yeah, so what we'll do now is Shashwat has already explained you how to work with the dummy data. Now we'll be integrating the whole API. Okay, so first of all, for that we'll be needing to make an account on the Rapid API. It's provided in the prerequisites. You can open the link of the Rapid API from there, and as you can see over here, once you sign in, you'll be redirected to the sign in page, to the dashboard, and where you'll have to now, okay, now you'll see the apps feature over here. Once you go to the apps, what you'll need to do is that you'll need to create an app. Like I've already created a GDG event app over here, where you'll be provided with an authorization token, an API key. Now, now that is done for the time being. Now we'll move to the site and we'll search for the API that from which we need to fetch. Like I'll write the IMDb API. And the third option, that is the blue colored API, is what we are using over here. So we can see that in the title get popular v2, that is title /v2 /get popular, we'll be using this API. Now as you can see, there's the API key and there's the request URL over here. Now what we'll be doing is I'll test this endpoint and I'll let you know. So while it, yes, okay, so like when we'll be fetching the movies right here, so as you can see over here we have the edges and we have 20 entries. We have 20 entries, and inside each we have the node, we have the title text, we have the title type and the image and everything that we need. So now let's proceed to the code part. Okay, so the Shashwat's code is already uploaded on the repository. If you're lacking behind, you can pull it. That's fine. So first of all, what we'll do is we'll remove this dummy data. And now, okay, so first of all, what we need to first of all maintain the state. So what we'll be using a use state. So for example, over here we'll have movies and set movies. Now what is set movies? Set movies is a function that is used to change the values of the movies use state. Okay, so we'll use a use state. Now it will import, and initially it is going to be an empty array. Similarly, we'll also check whether the API is still fetching. So we'll make a use state for is loading, and secondly, the same function like set is loading. Set is loading, and the use state is currently true because initially we want the API to fetch the details. Now we'll also want to check the error. So we'll make another use state and the same function for that, like set error, and initially it is null. Okay, now what we want to do is we are wanting to fetch the API. Now as you can see from this, we are been providing these headers. So you need to copy these headers. I'll copy these headers, just a second, and then okay, now we'll move to the code. Now completely we'll have to, now how do I want to proceed with the code is the question. we want that every time a person opens the website, he or she is being displayed all the movies that are being provided by the API. So for that, we need a use effect. Now, what use effect does is, while I'm writing that, I'll explain you. So a use effect is basically a a React hook, and what it does is it executes a certain set of codes inside certain set of code inside the use state only when the set of array only when the variables in the set of these arrays are being changed. Now, what if I leave this array empty? If the array is left empty, it will execute when the when the page is reloaded again. So that's how use effect works over here. So now let's make a function over here to fetch the movies, and we'll use an asynchronous function to fetch the movies. So moving forward with that, now what we need over here, we need to fetch the movies, right? So what if there's an error? How are we going to validate that? So we need the try and catch block. So we'll make a try and a catch block, and we'll get the error over here. So error. Okay. So now what we have to do? We have the endpoint from where we have to get the. So this is the endpoint over here. This title /v2/get popular, and the endpoint is also mentioned over here. So we can use this, and we'll proceed with that. Okay. So now what we'll doing is we'll get the response. Constant response is equal to await, because it's an asynchronous function. And now we have to enter the API link. So the API link is HTTP, because we are using Rapid API. So the API is of the Rapid API only. Okay. So and we have been provided the link over here. Okay. So now we'll move with that. So imdb.8.api. Okay. And .rapid API. Sorry. From here, yes, I'll just copy this. This is the further URL. Oh, sorry, this. Yes. And when we'll paste this over here, then we'll add a slash and we'll paste the path. Then we have to specify the type of request that we are sending to the API. Okay. Oh, it's a double slash. No. So then we have to specify the type of request that we are sending to the API. So now we'll be moving forward with the type of request. So the method that we are sending over here is a get request, as we are trying to fetch the requests. Okay. So as we are trying to fetch the data, now we'll be proceeding with the headers. Headers, we know we have copied from that, and this, and I'll insist you not to use my credentials over there and try to get your own credentials. It's a very easy step, and it's also mentioned in the prerequisites. Okay. So this is done. Now this response will be fetched in the response, but is it all but we have to verify it, whether the API is giving the correct response and what is the format in which it is giving. Okay, so we know that the format is correct. So now what we have to check whether the response is correct or not. So what we'll do, if response is not okay, then we'll throw an error that something went wrong over there. Okay. Now what we'll do next, then we have to, if the response is all right, then we have to convert it into a JSON format to parse it into the different components that Shashwat has already created. Await response.json. Okay. So this converts the response into the JSON format, and which will be easy for us to parse any response that Shashwat has, any incoming response into the component that Shashwat has created. Moving forward, we'll have okay, let's analyze the results from here. Okay. So as we see, in the 0th index, we are being provided with a node. Inside the node, there's a title text, and inside the title text, there's a text which is being passed as widget, which is the movie name. So we have to use that, and we have to display it so we'll be destructuring the data in such a way that we can get the movie name. So what we can name it as, transformed movies, and we'll be destructuring the data now. So what is data? Data is the variable name. Now we'll be using data. Now then inside data, what do we have? We have data. So we'll write data. Then what do we have? Then we have movies, because we have to fetch the movies. We'll write movies. Then what do we have? Then we have the edges. Then we'll write edges. Then what do we have? We have the indexes. Okay, so now what inside the edges, we'll have to map it. We'll have to iterate over all of these, and we have to get the data from that. Okay, so what we'll do, we'll map. As Shashwat has already told you in a very interesting way how maps work. So I guess it will be very clear for all of you. And inside every edge and the index, now we'll use the map function. And moving forward, okay. Okay. Now what we have to do? Now we have to get the IDs first of all, because every time the ID is required. In this project, we might not require the ID as much, but generally we require the ID. So what we'll do, ID is, what is the ID now? Now ID is the edge dot node dot ID. Now how am I getting this? Let's see. Edges, we move into the edges. Now when we are iterating over a particular array object, so we see that inside supposing we are inside the 0th object, and inside this node we have this ID object, and we are getting that in this ID. Okay, moving forward, what if there's, okay, let's move forward for the time being. Now we'll get the name. Similarly, edge dot node dot title, no, title text dot title dot text. Okay, title text dot text. Okay, this gets us the title. Now we'll need the image. So what is the image? Image is edge dot name. Image is in the primary image where we have the URL. Okay, so node dot primary image and the URL. Okay, now we are getting the image, we are getting the name. What else do we need? We need to run this to get to know what else do we need now. So just a second, it will run, and then we'll get to know what all do we need. Now, okay, it is running. Oh, now we can see that we need the rating, we need the names, we need the genres, and the poster image. So what all do we have? We have the name, we have the poster image, but we do not have the ratings and the genres. So we need to write a code for the rating. Okay, so what is the rating over there? Let's see, where's the Rapid API? In this. Okay, so the ratings are being provided as ratings summary and aggregate rating. Okay, so we can use that ratings dot node dot ratings summary dot aggregate rating. Okay, that is fine. Rating is being done. Now genres, we have the title genres and 3 items. Okay, now there can be a scenario where we have more than 4 genres. Now when there are more than four genres, so the layout of the website might change, and we can see that some of it is very grown and some of it is in the same height, and some of its height is different. So to avoid that, what we'll do, we'll restrict ourselves to only maximum 4 genres. So for that, what we'll be doing is we'll go to the genres section, and then we'll dot title genres first of all, title genres, and now we are able to access the genres array. So what we'll do is we'll get the arrays dot genres. Now we have to restrict ourselves to only 4 genres. So what we'll do is we'll write edge dot node dot title genres dot genres, like inside the genres, and then we'll slice it. Okay, then we'll slice from 0 to the 4th index. Okay, so only the first 4 genres will be selected. Then we'll map this, and in the map we know we need the genres dot text. Okay, that's fine. And then this is in the transformed movies. Now we have the transformed movies, but are we able to use it over here directly? No, we cannot use it. We have to set the movies. So we'll use set movies as the transformed movies, and then we need to, now there's a loading state. You remember we made a use state, and it's saying that loading state is true. Now once the API is done fetching, we have set the loading, so we need to make it to false. So the now set loading has been made false. Okay, so now what next? Now what we have to catch the error, and we, let's say, console log the error. Okay, that's the basic stuff to do. Okay, so now we are getting any errors that are being uh, displayed. Okay, and this is done. So now we have to check when it's loading. We can't just give the user a blank screen. Like for example, this is now being removed. Now we are not having any popular movies. So this will be a blank section that the user is going to see. So for that, what we'll do, we'll add a, and we'll say if is loading, then what we'll do, we'll return a p tag, and we'll say a p tag, and we'll say loading. Oh, sorry. And we'll say loading, and we say that that the API is fetching the movies and then it will be displayed. Moving forward, we can do similarly for the errors, and we can say return p and the error. So the screen will now display, in case if it's loading, the screen will now display that it's being loading. Then in case if it's an error, then it will show that there's an error in the fetching. So this is what the basic functionality that I wanted to tell you guys. And I guess I'm short on time. So there will be a code provided in the repository. You all can clone that, and that's fully working. There's a little bit error over here. So you can refer that. And I'll now like to invite Arunava to continue with the presentation, to continue with the workshop.
Okay, so I'll be starting now, and the feature I'll be working on is basically the card feature. And uh, okay, so just because we are doing everything from scratch, so I will start from it cloning the repo. This is the repo URL, and okay, clone. Yeah, this is the repo URL. While it's being cloned, I will just explain what am I going to do, right? So this is all the movies that we have fetched from the API, let's suppose, and we now need to add them in cart. So if you click here, it will be added in cart. Ignore this part because the backend is down, so we'll do that later. For now, and yeah, this is being added here in the cart. And if you have noticed, we are also storing them in the local storage, which is here for all the movies. If we click, okay, let those just load, and okay, so it will load here. Also, if we try to remove them, it will be removed and also be removed from here. So let's start coding. Okay, this is taking some time to pull, so I guess I will just get it from local. Yeah. So get in here, and yeah, this is it. This is what we have done till now. And okay, I need to first set the comment. 1 second. This is empty. Just a second. Yes, so we'll start from writing the useState function here, which will have all the cart items. So in React, we can use cart, and this is just array destructuring by the way, and set cart. And here we can use useState. Make sure you have imported this from here, else it will not work. Now here we will write a function which will return some data. I will explain that, and store them in the cart. Okay, so the function is something like this. First we'll take a variable and const stored items and get it from local storage. Okay, local storage is a browser API which if you read in the MDN docs, it is very well explained there. And you can there is a get method on here, get item, yeah, and you can call it with, it takes a key property which is just cart for here, as you might have seen here. That the key is cart and the value is empty array, and after that we'll return it, the stored items, not like this. And if this is there, we'll return that like JSON parse and just return it. If it is not there, then we'll just run an empty array object. just as you can see here, which is on refresh, it will be always initialized as an empty array object. Now we will have use effect function here, which will be snatching the snake whenever the card item changes. So I will just write the wrapper function from now and come to this later. It takes a function again and comma, and there will be a dependency array. So I'll be explaining that later part. And now let me just write to the main functions, which is add to cart. And yeah, it takes the movie object, which we'll get from here, cart items and movie list here. Add to cart, and here will be pass this function as a prop. And similarly, we'll have another function for removing from cart. Okay, yeah, we'll be writing those again. But we could just pass those as cart items, or it's this cart item is being displayed in the cart page, if you have noticed. And here we need to pass this as a prop again. Remove. This one. Now we need to write those functions which I had kept just here. First, in add to cart. In add to cart function, if you have noticed that we are also sending an toast message here. For that, we are using a library, which is this thing. Let me just go. Yeah, React Hot Toast. This is a very popular library, and let us send messages like this, which you can just install via yarn-add or whatever package manager you use. And then first we'll get the movie item, movie in cart. And if this is in cart, okay, here we are finding basically if the item is already in cart. I'm explaining that part. Okay. This finds with the item ID if there exists a similar one in the movie object. Okay. If this does, then we can't add that in cart again. So we'll just use React toast and toast.error and say that item already in cart. And if not, then we'll add it in. Now you might think that we'll just use the set cart function here and do something like this: set cart and local storage dot set item to whatever we have reset from here. No, it will not work because it will just reset all the things we have reset there, and it will just get that item and add this. But we need all of those, so we need to use some JavaScript methods here, which is pretty clever, I guess, if you know. Set cart and the array here will take all the cart items which we had before. This is just resulting in JavaScript, and then at the end we'll append whatever the movie is, which is this thing. Yeah, now it should work. Now similarly we need to write a remove cart function. The remove cart function is again we need to find if there exists already one, or if not we need to check that, because we just can't remove the movie item which is not in our local storage. So here we'll check, and after checking we'll okay, if this is true, and then we can't add this in the cart, so I can send a toast error message that item not in cart, so we can't remove it, else it will be added. I mean removed. We are writing the remove cart function, and to remove it, we need to find it. Like we can use the set cart function with the use state providers us. And here we will filter all the cards, card.filter, and we'll get all the movies. Here we'll be looking for movie.id, which matches the movie ID. And this will be passed here. Where are you getting it? We are getting it from here. This completes our remove from card function. And for the add to card function, we have this. Now, the last thing that I need to talk about is the use effect here. In use effect, basically it renders whenever the dependency array changes. For example, if you see here, we have the cart thing. And whenever we add something in cart or remove something from cart, it will return the function. With the function we will mention here. Okay, so for dependency array, we are adding cart here. And in the function, it will basically rerun this thing. In the local storage, cart and add or remove the thing that we have there. For let me just write and explain. Local storage dot set item, local storage dot set item, and it will have the cart, yeah, the key cart, and then JSON dot stringify all the thing we have. Spelling out here. Okay, I missed this thing. Yeah. And that's, I guess, completes all the things we had. We have successfully written the add to cart function, which is being passed here as a prop. The add to cart function is simple, and same we are doing for the remove cart function. It's also simple. I think I am done. Next, I will pass to the ML team. Thank you.
Okay, so audible? Alright, so this is Anant from the ML division here at GDG, and now it's time for us to build a bespoke machine learning model. So this machine learning model will be one of the chief attractions of your project. This is the way for you to give personalized recommendations that appear to be humane and personal, but are motivated by math and artificial intelligence. So next slide. Before we get into the good stuff, we need to clean house a little bit. A machine learning algorithm needs data, and not just any data. It should be clean and it should be pre-processed in a certain way. And most importantly, it needs loads of data. So let's find us some. In your prerequisite sheet, you will find the dataset we'll be using, and it is in CSV format, and it contains around 64,000 data points that our model will use to drive recommendations. So first, you got to clean it. So that includes removing duplicates and handling missing data. And then, depending on the machine learning approach that we are using, sometimes you also have to wrangle with the data a little bit. So here, our model will be assigning title and genre to the same class, that is description, so that we can choose to create a column called description and append these two attributes to it. Then next slide. You have to tokenize and generate embeddings. And what does this mean? Well, a machine learning model needs to be pointed in the right direction for it to go look for and learn from what you want it to learn from. So tokenization is basically little Easter eggs that we hide in the data in a way for us to tell our model to go find them and become smart. And then the embeddings that we leave through there will be used by a recommendation algorithm, which brings me to the final step, which is implementing a recommendation algorithm. You choose an approach that aligns with your data and use case, and if you're lucky, it works. And if it doesn't work, then you try again. Let's pray to the data gods, and I'll hand it over to Sahil to see if it works for us.
We have done two models for project, cosine similarity. Cosine similarity didn't make it to the final stage because it was heavy. And why is it heavy? I'll explain a little bit. So what is your cosine similarity? It is a metric that you can use to calculate the similarities between sentences. Like there are these 5 sentences. 2001 is Space Odyssey. So what cosine similarity will do is it will tell us that the above 4 sentences are sentence is very different than before. Because and how will it be do it? We will first make a table of the words, plot the points, figure out the angle between them, and calculate the cosine of the angle. And by comparing the cosine, if it is acute angle, it will be very similar. If it is 90 degrees, then it thread. And if it is obtuse, it is opposite of the verb. And only two words, but if there are more words like three or four, then we can use x and y axis. We will want to use more dimensions, and we can plot more dimensions. So we use a formula, which is this thing. Now, so I'll just explain it in a overview of what functionality is. So there are few sentences.
Sorry to interrupt, Sahil, sorry to interrupt, but some people are saying they're not able to hear your voice properly. So, if possible, can you like tune in your microphone a little bit? Or if possible, you can also use your system microphone.
Yeah. What about yes. Okay, so these are three sentences. Hello world,
Yes.
hello world, and hello world. So the first sentence contains hello and no world. The second sentence contains world but not hello. And the third sentence contains both hello and world. So what we do is consider the x-axis as hello and the y-axis as world. This is represents hello. The first sentence is represented by this line, that is only hello, and the second sentence is represented by this line, that is only world. The angle between them is 90 degrees, and cos of 90 is to 0. So they are not similar, they are very different to each other. And if we include the third sentence here, hello world, this is the line between these two lines, hello and hello world, is an acute angle. That means they are quite similar to each other, not completely similar, but they are similar. So that is how cosine similarity works. Now let's see the code. Uh, okay, I have created a I have already put the nv files, .nv files, which contains the API key of OMDB, the API that we are using to fetch movie posters, and you can get it from omdbapi.com and then go to API key and just choose free and put it on your mail and to for the API key. And for the dataset, we are using TMDB movie dataset, which is available at Kaggle. You can download it. It's 215-ish MBs. And after doing this, just create a NV file and put it on your API. So let's jump to the code. And also for the requirements, these are the that you will need to install using pip. I have already installed it in my virtual environment, so I will jump to the code because we have time constraints, or else I would have showed it to you. I will explain these imports in a bit. So first, I key from that .nv file, and this is the general syntax for it. And then there's the model file and sparse file. What is this model? Model file is actually a serialized model that we created using this pickle. It's a model that has already been trained and put in a single file so that you can delete the dataset. So I have already implemented the get poster function because it was mostly just following instructions from OMDB API and just try and accept things. This link is given by OMDB itself, and part of that of a JSON thing that is fetched from OMDB while fetching. So let's implement the vectorized data function. What it does is it gives a value. It gives like TF-DIF. There's something like TF-DIF, which is term frequency, and the TF. What was it? TF-IDF. Yeah, TF-IDF vectorizer, which gives how important words are in the sentence. Stop words equals English means um, to remove the importance of words like and, the is common words in English. You can change it to any other language, but I'm sure you will use English. And we are doing it on the overviews of movie. If there is a movie, then how important each word of the overviews of that movies are. Then there's compute similarities function. We just use the cosine. There we imported the cosine similarity above from scikit-learn. So we're just going to use that imported function, cosine similarity. Similarity. Okay. Um, OV matrix. On the OV matrix is the overview matrix, which in each word to other words, other overviews. Okay. Then there's the recommend movie, I would say. Uh, we first convert the uh, input from the user to lowercase so that it is standardized. Titles equals, and also the fetched titles from the OMDB API to lowercase dot store dot lower. Okay. And then there's if, and what if the movie doesn't exist? So there's this function if movie not in titles dot movies print uh, movie not. I don't think I maybe have to movie not on, and we return an empty array idx, and then there's the idx which gives movies titles equals movies. If the index is equal to the index fetched from the API, then we put it in the IDX, uh, what is it called? A variable. Sim the similarity score, which is the cosine similarity score by computing the function. So OVSIM already consists of the similarity scores. Uh, OVSIM IDX, OVSIM IDX, huh? OVSIM IDX similar, and then there's the index of the movie that is similar to the movie that the user typed. IDX represent the movie that the user typed. Similar IDX represent the movies that are recommended by the model. Similar codes. And what we are doing is sorting the sorting the movies. We use argsort because the uh, generates it from, but no, numerically, like the lowest score is at the top. We are removing the movie itself from it because the movie itself will surely have the same overview, so it will have cos of 0 degree, which is 1. So we don't want that. So we are fetching the 6 movies and removing one of it. Okay, I think I will have to make it faster because we don't have much time. If oh, I'll just source the code that I did and copy it here. Downloads recommend. You can see the to you in a minute. But first, let me run it. Like what you will get after doing this. Sorry, it's because of the time constraints. It's 2:29. Okay. Begin model not found. Creating a new one. It will create OV matrix file, which the model file already contains the similarity scores. Let's say inception. So yeah, it will tell you the title, the poster. You can open the poster. This is the poster of that file. And I have deployed it on Gradio. So that's it for my part. I'll share the links. Now I'll like Aryan to take over.
So, hello everyone, I'm Arihant and I'm serving as the ML lead. So, we'll begin with a presentation first on why we didn't go forward with this model, right? Cool. So we didn't go forward with this particular model because cosine similarity took about 500 to 1 GB space, and we can't push that into, let's say, production, right? So let's, as we usually do, let's pivot. So how we are pivoting, right? So let's use transformers. So all of us are using GPT, right, every day. And so let's look at something which is the foundation behind it, right? Okay. So we'll begin with the PPT session first. Okay. So you guys can see this, right? Cool. So imagine a technology that can understand language almost like a human brain does, processing entire sentences at once instead of word by word. So what are we doing is, let's say entire context you're getting at once instead of saying word by word. And this was done by Google. Google's were the founder of this technology. It's done under the attention is all you need paper in 2017, right? So before this we had some, let's say, techniques to process context. We used RNNs and so on and so forth. But let's say this model was revolutionary in the sense that it used the entire context at once, right? So how do we define context, right? Context isn't just key, let's say it's a word by word thing. It's like word and how is it positioned compared to other words, right? So let's say if I am using the word I is usually followed by am instead of say are or say like, right? I am is a usual connotation used when introducing yourself, right? That's how things are processed here. So there are four steps to any transformers, right? There is an encoding part where we encode words into, let's say, numericals. There's a key value creation where, let's say, for every word there is, like, let's say a query like what do I need, and let's say a key like what do I have currently. And these key value pairs are what mix match to get us our encodings. There's this attention mechanism, we'll get onto that, which helps us process things fast. Like what it is doing is it's taking the entire aggregate of your past and giving it to you at your present state. So like best example I can give you is sabne Gajani dekhi hai, right? Gajani movie. Just remember how the person forgets things. Transformers before 2017, ML was like that, and after 2017 with transformers we have come into the new era with GPT and all. That's the old that's the old person, right? And so there's finally a decoding session where whatever embeddings and everything we get, we are then reconstructing back our sentences like originally we had, right, in the encoding part. Next, we'll talk on token embeddings and self-attention, right? What all buzzwords I'm using, right? So what are token embeddings? So let's say there's a sentence, right? Any sentence contains words, and words are like we can represent them with numbers, right? So let's say NLP used this concept of turning words into numbers, but there is no context attached to things, right? Currently, as far as we are concerned, there is no context. So every word for every other word is equally likely to happen. And so instead of token embeddings, you also use positional embeddings. So let's take an example, right? Let's understand things a bit. So we see this sentence, the big brown fox jumped over the lazy, right? In this sentence, this is our context length, by the way. In this sentence, we have indexed things based on, let's say, zeros. So this is zero index 1, 2, 3, 4, and so on and so forth. So this is our token embeddings. But the positions, position 1, position 2, position 3, and 4, these are the positional embeddings of the things. So using both position as well as tokens, both of these combined together give us our model. What's attention? Now let's go on to attention mechanism, right? So attention was, let's say, a concept which was developed to say give us our past at our current state. So how do we define our past? So what do? We take aggregates, like let's say multiply our past with a certain number, and that experience, like how valuable that experience was, that's the aggregate we are taking. So like let's say this example right here, right? CLS means new line, and let's move on, right? So the itself doesn't have much context behind it, but let's say the word is children, right? So children has some context attached with children. Children is highly contextual with playing and garden. These words in the, these are very common words, like very common words usually don't have much context attached to them. Words which are very unique and are, let's say, consequential to each other, they have higher context. That's how we process things. We are taking the word itself, a number attached to the word, we are taking the position attached to the word, and how likely are these things related to each other. That's how we process things. So sentence transformers, the one we are working with, is an implementation of transformers, right? Many implementations have been there. Sentence transformers is an elegant one. We process entire sentences here, and then we get entire sentences out of it as well. So we write usually queries, right? Like Claude hai, we write queries, we get output, hai na? It can be summarization, it can be a generation part, like that. So what we're doing here is, this is an example of what we are actually doing. So let's say there is this import hello world. We are getting output again as hello world, let's say. But what's the intermediate vector? What's the machine processing? So the machine is seeing a position of 0, a position of 1 for hello and world. But there's a token value attached to it. Say, let's say token value of hello is 10, token value of world is 15. Machine sees 0, 10, 1, and 15, and then it mix matches things inside to see what is the actual context. So while it is processing, there is a certain chance it will also generate world hello. There is a certain chance it will only generate hello, only word, and then there is hello world. But contextually speaking, hello world is highly contextually likely to be presented as a final output, because it's entirely a predictable model based on let's say probabilities, right? But probabilities here before 2070 were like equally likely for each word, or let's say minimal context. Like let's say pehle there was this thing like एक word होगा, you have the context before it, only one word context है ना, एक पीछे का word you have only, that part is your context. You can't do much with single word, right? But let's say you are processing an entire sentence is getting processed, the entire context you are getting ki what is the sentence talking about actually, right? So let's move on to a coding session ki how are we implementing this, right? So in this prerequisite file, I had asked you guys to create a Kaggle ID and use the following datasets, right? So we will be following the second dataset, and we will be creating a Kaggle ID here. So if you guys haven't created a Kaggle ID, please do, and we will be using this, right? I have already, let's say, I have set things up for my end. So this is what you will be seeing, right? And here we will be using a new notebook. I'm sorry, this is taking a bit of a time. Load होता रहता है, तो हाँ, we are getting things done, है ना? अब this part is the data set, है ना? यहाँ पे you are getting a data set thing, and here this is your output section where whatever processes you have done, outputs will come here. This is the code based kind of thing. यहाँ पे you write code, and let's say यहाँ पे accelerator भी है. So let's say neural networks take a lot of time to process, right? Accelerators can help you with that. So let's say we set our accelerator to say GPU T4, and of course Kaggle has a quota kind of thing, so you have 30 hours to work on. And let's start coding, right? So we'll be deleting this, and we'll first import libraries. So like import pandas, this PD, import, let's say sentence transformers as sentence transformers sentences, sentence transformers as sentence transformers. Then we'll also use torch. Torch is a, let's say, another implementational library against Keras. Google is highly dependent on TensorFlow and Keras. Those are its creations. And there's also functionality, import torch dot nn dot functional as if. There's also we will be using, let's say, like how Sahil did, we'll also be using cosine similarity, right? From sklearn dot matrix dot pairwise import, let's say, cosine similarity. Whew, cool. And let's say we didn't have enough time, right? But let's say we did have enough time, we wanted everything customized and so on and so forth. So we can also use this. This is the OG, let's say, transformers repos import, auto tokenizer, and auto model. Cool. These are all the libraries we need. No model in a sentence transformers. अरे यार इतनी स्पेलिंग मिस्टेक कब से करने लगा मैं? हाँ शायद I would have to get things in order, है ना? Let's say यहाँ पे we write pip install sentence transformers. अब चल जाएगा शायद. हाँ स्टार्ट करनी पड़ेगी. लेट्स गो अलॉन्ग, है ना? लेट्स से डीएफ हमें एक चाहिए होगा, डीएफ या मूवीज बोल दो. वी विल बी इंपोर्टिंग अ डेटा सेट, राइट? हमने डेटा सेट लगाया है क्योंकि डीएफ हमारा होता है पीडी के थ्रू, पीडी डॉट रीड सीएसवी फाइल. रीड सीएसवी विल बी यूजिंग दिस. And we can see कि this is getting properly loaded using head. We'll be using 3 heads. So like top 3 values from the data set. Cool. We are getting things done. And then we will go on by enriching our data set. So what let's say sentence transformer does is it uses sentences, right? So it needs to be sentence gens. So what we will be doing is movies के अंदर we will make another column, say description, such that description के अंदर we will do let's say title we are making. हमारे पास title है, and what we are doing is title के अंदर हम attach कर देते हैं हमारे titles. So movies के titles, and we make it like genre as well, है ना? We have genre as well. Genre movies and genre. Cool. This will show us कि movies के अंदर के descriptions we will get, है ना? Same movies dot head से we will find कि everything is in order or not. Genre you can't find, है ना? Genres spellings. So we can see that now this description variable description column, let's say, is enriched with title as well as genres. Let's say we add more description values, right? Let's say we add ratings. Let's say we add let's say original description of the movie. The more enriched this is, the more better results we'll find, right? That's how things work in transformers. So let's say we wanted custom embeddings, custom everything customized, है ना? So what we would be doing, we will writing 2-3 functions जो कि they are based on let's say कि you are using customized things, right? तो तुम embeddings we will find customized, tokens we will find customized. So what we do is mean pooling, and mean pool will be doing model output, which we will be using the original transformer here, and attention mask. So what this does is token embeddings निकालता है model output के 0th index से, and then we will put the index input का mask we will make apply and then apply it, right? Token embeddings and size and will be dot float, and then what we do is we'll be returning, let's say, our mean pooled results dot sum. So what this entire function is doing is let's say the concept behind it is let's say attention mechanism, right? So what this is doing is token embeddings we are taking out. We are taking a mask, attention mask, and attention mask is basically finding the context based on the past aggregates. So this is getting applied to on top of that. We are let's say unsqueezing things, or let's say taking out things inversely or -1, let's say backward through, and then we'll sum everything up and send it back by, let's say, doing this. Token embeddings को we will be multiplying with, let's say, input mask expanded. हमारा जो token embeddings we have multiplied with input with our input mask, right? We multiply in token embeddings with mask, and then we find actually what context behind every token we have. At the first dimension we are doing this, and let's say lamp कर रहे हैं यहाँ पे इस point पे, right? Torch dot lamp. We put input expanded mask, mask expanded. Dot sum. At first column, minimum at minus, let's say, E1 of E minus 9. So this is 10 raised to minus 9, right? This is minimum value. And so this is the minimum value set. Let's say 10 raised to minus 9 is almost approximately 0. And so this is 1. Cool. This is our custom function to, let's say, get mean pooling. There's also a custom function to, let's say, get the embeddings as well. Let's move along a bit, है ना, वरना let's say जो production वाला काम है वो will never get to that, है ना. So let's say this is the embeddings function. Let's say pre-written मैंने रखा है अपने side क्योंकि. So what we are doing here is sentences we are taking encoded input में we are using tokenizer. So this tokenizer we have, let's say, based on this. This is from original transformers, let's say, library. What we are doing here is we are taking this auto tokenizer from pre-trained model sentence transformers ka this version, and this version is getting us tokenizer. Tokenizer is something like, let's say, we'll process it and get tokens out of the sentences. This is the model we'll be using. Again, auto model pre-trained based on this. What we are doing here is हम sentence लेते हैं, we are tokenizing it based on same padding level, same truncation level, and we are returning tensors, है ना. And then in with torch no grad, मतलब यहाँ पे there is no gradient descent. So what we are doing is model को हम encoding में डालते हैं, we are training model once, इसको mean pooling में डालते हैं, and we are getting the attention mask thing, and then sentence embeddings we are using normalization. So what this does is sentence की actual embeddings निकाल के दे देता है हमें, right? So we run these are customized models, custom point of view. So इस point पे we are not let's say we are not going to use these. What we are doing is let's say something very innovative, है ना. What we are doing is Sahil found cosine similarities, right? Cosine similarities tell us कि how likely each thing is to each other, right? Like let's say two sentences एक दूसरे से कितने likelihood related है. So what we are going to do is हम वो concept use करेंगे, we'll use that and get our sentence embeddings here. So let's say हमारा मॉडल रहेगा सेंटेंस ट्रांसफॉर्मर्स का वही वाला वर्जन. So let's say model equals sentence transformers. and let's say sentence transformer slash all min all millennium millennium L6 version 2. Okay. And then what we do is we also use let's say token embeddings. Now let's change the word, right? Token embeddings, we are talking in terms of sentences. We are using movie embeddings here because we are always let's say variables based on what we are working on, right? So movie embeddings is based on model.encode. What this model we are encoding let's say our sentences or movies here, and what we are encoding right now is the description section we have created backward, right? This part, this thing we created, this is the enriched let's say description for titles and genre. We'll be using these है ना, movies का we'll say description है ना, this will get here, and what we are going to do is we'll convert into a list. So to list, model object is not callable. Sentence एक second. Sentence. कौन सा वर्ड मेरा था? कोई ना. The thing is supposed to work like this. Sentence transformer model will load. हम इस मॉडल को इस पे एनकोड कराएंगे, एंड व्हाट वी विल डू इज हम यहाँ पे लेट्स से रिकमेंडेशन फंक्शन लिखेंगे, def get recommends, and what this is going to do is we'll take a query जो यूजर लिख रहा होगा, and we'll use the embeddings we have on hand. We will use the data frame. Let's say यहाँ पे movies data frame use कर रहे थे df, and then top n values. So let's say हमें we want to use top 5 let's say movies है ना, this. And what we are going to do is we will find query embeddings by let's say model.encode based on query. Similarities, we'll use the similarities from cosine similarity like what we used before. This is going to use the query embeddings we have, and embeddings that from the movies है ना, and what we use is top indices. We find top indices based on similarity scores, 0th index of that, by R sorting it. So let's say most let's say things get let's say highest similarity score gets on top. We are trying to implement that है ना. So we are arc sorting it based on let's say minus of top n, and what we do is यहाँ पे we will use this. This will let's say find let's say all of these recommendations. It will take out the let's say maximum of it, and that will get pushed into let's say our model है ना. So let's move on है ना. This function gets run. यहाँ पे will return top indices, and this will get things done है ना. So now let's say इतना part run करने पे you will have your model ready. This model on running will let's say a piece of code is this. This will help you save your code है ना. We'll be using pickle like how Sahil did. This will save your model. So what we are doing here is we are using let's say this model. We are using this encoding methodology. We are let's say writing this function that finds the similarity scores and returns the top indices, and we will be saving our model. So this will get outputted here. You can download things from here है ना. This is the working directory. And let's say we also want to load the embeddings, right? So we will also need this. Let's say here. These both will get us our model as well as the embeddings we have found so far based on similarity scores. I have stretched things a little bit far, है ना? This is very code intensive to an extent. But what you need to understand is basically this. There's a model here. There's a tokenizer here. These both will be getting things done using these get embeddings and mean pooling if you were to use, let's say, custom function. But what we are trying to do is हम already similarities को बात कर चुके हैं. So we'll be using similarities course here, a model, an embedding. We'll get things done here. We are using cosine similarity. We are finding which is the best, let's say, based on that. And we are returning top indices. So top 5 movies. We are saving our model, let's say, for production. And let's say this part will get things done for embeddings. So agar embeddings nahi honge, to model won't be able to find things, right? That's how things work here in ML. This model, let's say, will turn out about 70 to 80 MBs. So let's say for 500 from 500 to 80 MBs, it's very let's say good. Because production pe you can't just push 500 MBs, right? Get LFSB, let's say, takes time a lot. 500 MB, 2 GB in sab pe. So ML ki side se this is all, and I'll be forwarding this to the backend team. Thank you.
Okay, so like every other project, we need a functional backend for this one as well. So a good backend is lean, it's not unnecessarily complex, and it works as intended with minimum load on the client and the server side. So let's see how to build ourselves one. So we're going to be using Flask. So Flask is basically a WSGI micro web app framework that is written in Python. And I know that is a mouthful, so let's just break it down. It's called a micro web app framework because it doesn't need any tools and libraries to work. And WSGI is just internet speak for web server gateway interface. It is lightweight and it is designed to make getting started quick and easy. But don't be fooled. It is perfectly capable and shines when it's time to scale up to more complex applications. We're going to be using it here to build APIs because of its simplicity, flexibility, and minimum setup requirements as we discussed. So let's talk APIs. Well, they really are the way how data gets from here to there. It is what makes possible all the interactivity that we've come to expect and rely upon from the computer land. But what exactly is an API? It's not really a question that anybody asks, but I'm glad you did. So the technical definition is, as I've written here, application program interfaces are a set of protocols that allow two software programs to communicate. But let's speak plainly. APIs bridge the gap between different software systems so that they may talk to one another and share useful info. So as you see here in this representation, you, the client, sends a request through the API to a server. The API relays and processes it to the server. The server does the required task and sends it back through the API in the form of a resolved query. Here, that's going to be fetch data for movie recommendations. So here we're going to be working on a popular principle called CRUD. That basically stands for create, read, update, and delete. If you decide to study DBMS and SQL later in depth, CRUD will become sort of a Bible for you. For create, APIs have post calls to create resources. For read, we have get queries that retrieve resources. For update, we got put calls that modify resources. And finally, delete is just delete. But here we're going to be using a special sort of API that is a REST API. It basically stands for representational state transfer. Don't be fooled by the name, they are just for communications from client to server and vice versa. Its particular perks due to which we're using it here is that it is standardized. So as you'll see soon, no matter what, at what point and whatever it is that you're writing the API call for, if it is in the correct format, it will retrieve the data. It is also stateless, which means that you don't have to worry about what state the data is in that you're trying to retrieve. Just as long as you write the right call, the RESTful web service will fetch it for you. And finally, they're really quick, really high performance because it supports caching. So sometimes if you're asking for the same resource over and over, it'll simply cache it. So the next time you ask it, it might not even go to the server. It's that fast. So with that, congratulations. You now know enough to go build your first RESTful web service using Flask. And don't worry, what you don't know, you'll learn by doing. I now hand over the terminal to Harshvardhan to discuss the backend further. Thank you.
Yeah, okay. So we got a bit deviated right here. So now let's come back to the project that we will be building today. So here's the user flow. So basically, here's a homepage. And now the homepage, if we choose an option, if we, from the popular movies, if we add any item to our cart, we'll be sending a request to the backend, and which will in turn send it to the ML model. And then once the ML model gets the query, it will recommend us some movies. And then once we get the movies from the as recommendations, we'll send those names of the movies as recommendation to the OMDB API, which will give us the posters, the ratings, the genres, and all that filler stuff for the movie, and then we'll then render it on the home page. So now, without wasting any time, I'll like to show you what we'll be doing basically in the code. Next slide, please. Yeah, so what are we going to do in the backend? So first of all, we integrate the API to fetch the movies, and then build a Flask API to integrate with the model, and then request the MDB API to fetch the recommendations, and then integrate with the Flask API. So now I just like to share my screen. So could you please disable your screen so I can share? Yeah. Just a minute. Yeah, so I hope my screen is visible. Okay, so here's a basic prototype of the model that we had built, that the ML team had built. So now we have just set it up in Flask, and then it will just accept. Here we have added a post method for it to accept any request that will be sent through the front end, and then it will return the data for the movie name. So for now, we'll just start the server and test it out once. So now I hope now with this, I'll just turn on the server, and then we can be testing it via Postman to check whether it's responding well or not. So here's it done. I'll just share my Postman API once. Just a second. Yeah, so here's the Postman, and now as we see here, we'll be setting it. We'll be sending the request to the recommend endpoint at the localhost and port 5000. And as we send the request, we'll be having the body as the query as Titanic, which is a movie which we have chosen. And then here are the recommendations that the model gave us. First of all, it is titled the Titanic, title as Titanic, and then here and all. So now what we'll be doing is we'll be forwarding these movies.
Your screen is not visible at the moment.
Oh, okay. Just a minute. So I'll fix it. Yeah, is it visible now?
Yes, it is.
Yeah, okay. So I'll just run back what we did first. So we send a request to /recommend endpoint at port 5000 on localhost, and here's the body of the JSON data in post method. And as we send this, here's the response we get by the model, and here are the movie recommended for Titanic. And now, as we have received these movies as recommendations, we are storing the movie names in a separate list in Python, and then sending the request back to the OMDB API here. So here's an example. Let's assume again then our API that our movie name that we got recommended is Titanic. It for sure isn't the case. But now let's assume that Titanic is also the movie that we got recommended. So now we send it as a parameter, and the API as a parameter to the OMDB API. And as we send it, we get all the more parameters about the movie, which is the poster, the IMDb rating, the name of the movie, the genre, and all that. So here's the basic part. Now let's move on to the coding the backend to add and integrate with the front end. So I'm hope. Okay, just a second. Yeah. I hope my screen is visible. If not, just a second. Yeah, it's visible now. So here we have the basic. Now what we have to do is basically whatever we receive as a response, we'll have to send it to the front end, and then means the OMDB API, and then So right now, as we have time constraints, I'll be just sending the request. I'll be just copying the code from somewhere I've previously stored. Here's the code. And so what we are doing here basically is we are storing the movie titles from that we received by recommendations in a list, and then the list is now being the movie list is now being stored as something to send request to the OMDB API, as we cannot just send the raw names that we have received to the OwnDB API, and then we are just printing it here to testing purposes. And after that, what I like to do is store those and also then save the responses that we have received by the OwnDB API to in another list, which will be sent to the front end, which in turn will be rendered on the front end page. Yeah, here's the code. Don't worry, I'll make it available for you. Also, we have a request module here because we are sending a request from a backend to the API backend. So we'd like to import requests in Python. And then as we see here, what we are doing basically is we are iterating to all the elements in the movie list. The movie list, what did it store was all the movies that we had received. So now as we see that if we send the request, it will be means it will just have a different parameter every time. And then it will just append it to the OMDB responses data set. And in the end, what I will like to do is just change this to OMDB responses, because that's what we want to be sent as a that is what we want to be sent as a response to the front end. And one more thing I'd like to add is that we want this function to be triggered when we click add to cart button, so which will be done in the front end. So what we like to add is to the front end is like we'll be adding this thing to the front end, which is basically just that we are sending a response to this API which we did via Flask via Postman, which we are now doing it via the front end, which is on click for the add to cart function. The parameters here are the movie name, which for which the cat was added, and then this is the parameter to get the five recommendations by the movie. And here's a simple try catch method. So now I'd like to forward the flow to Weber, who will be explaining about rendering the front end.
So hey everyone, now I'm sharing my screen to just render the front end of the recommendation section. So here it is. So first of all, we have to create a file named recommended items in our component folder, and just we type RAFCE, which is like RAFCE, to just get the templates of React if you have installed the React extensions. And here we going to receive our movies from the recommended models, and this is our first division which will render the recommendation section. Let's give a class name it as
Web of your screen is not visible.
okay. Is it visible now?
No, yes, it's visible now.
Okay.
Yeah.
So let's give a padding to 6, and let's make the text white here, and let's also screen so that content stretch to the whole screen and it does not get mess up. Let's give a margin top to 10, and that's all for styling, I guess. Now let's give the heading for our recommendation section and a class name. Let's make the text some bolder and bigger. Also, let's center the text with some margins of, I guess, 6, and let's give it okay. Let's format it, and after that we have to assign another div with class names. Class name grid column, and for small devices, we have to constrain the grid so it looks better on like smaller devices. Call of with 2 and MD, and it's the MD property gives to the medium devices size like your tablets and for like mid devices. Also,
Okay, guys, I think that his network broke in between. So he was just showing that how the recommended movies will be shown on the screen. Ishank, if you could just show the final demo.
Yes, I will just a second.
So meanwhile, Ishank is sharing, I'll just explain what was he doing. He was just showing that what the movies which are getting recommended, how they are displaying on the screen, which Ishank will show.
So locally, this is a code that is present with me locally. Now you'll get this code in a while on that repository that is being provided to you. And once I add this to the cart, you'll see that these are the sections. This is the recommended for you sections, and I added Wicked to the cart, so you can see that the similar name movies are being recommended over here for me, and the popular movies are moving down. So this is what we were trying to build. That is all for the demo.
Yeah, so that concludes what we were trying to build. If now Athar could take over and conclude the event.
Yes. So hello everyone. So this concludes our day one of Winter Tech Break. I would like to make a small announcement that if you attend both the workshops on day one and day two, then you would be eligible for the completion certificate. And we may also ask you to send your projects if you follow. It can be the Android application or it can also be the movie recommendation website. And if we find that your project is really good, we will also reward you accordingly. So keep in mind that in order to gain the completion certificate, you will have to attend both the workshops. And another thing that I would be sharing the prerequisite docs of the day two. So you can save the link. So guys, in the chat box, this is the prerequisite doc for the day two of the workshop. So please go through this docs and follow all the steps to install Flutter. This would be very beneficial because Flutter installation and building takes time. So if you are able to do this in prior, it would be really, really great. So that's all from day one. We'd be concluding our day one's workshop here. Please, we have created some polls. You may be able to see the polls. Please vote in them. That's a way for us to take the feedback. If you have not already voted, please vote. And all the code, guys, would be updated on the GitHub repository. The GitHub, please save the links of the documentations of prerequisite docs of today's session as well and tomorrow's session as well. So we'll update every other link in that docs as well. So thank you, guys. That's it for today. I hope you all had a great day of learning and innovation. Thank you.